Okay, here's one of those questions where we start with a practical optimization problem and quickly turn it into algebra and differentiation. Just to get started on this, we start with a show that question, so that means that this is the end point. So the first part is where we actually do think about the practical problem, and we set up this equation for the volume. Your start point is this diagram, and you need to think about what this looks like when it's folded into the box. And the way to get to your formula for V is get the length and the width and the height of the box in terms of x. Okay, now to help you visualize this, in your chapter 6 booklet, in an early exercise, there is a series of pictures that show how this turns into the box, and that may help you visualize. But you should be able to see that when these bits are folded up, it's this kind of length that will be the vertical measurement, the height, which is easy to write down in terms of x, and then the length and the width of the final box will be the lengths of these dotted lines here, which once again you can express using the 9 and the 24 and x. If you get the length and the width and the height in terms of x, that gives you three factors. Two of them will be brackets, so I'm going to write them all as brackets. Three factors that you need to multiply together to get the volume, because volume is length times width times height. When you multiply that out, this is what you should get. But if you can't do that, the whole of the rest of the question is a re-entry point, because they've given you the formula for V that you're going to work with for the rest of the question, which continues on the next sheet. Here we go. Okay, so now we've got V. In B.1 it leads you through the process. Find dV by dx, so use your rule for differentiation from chapter 5 to differentiate powers of x. Look up your notes on chapter 5 if you've forgotten how to do that. Show that any stationary values of V must occur when this. It's show that this is the end point. What's your starting point? Your starting point is stationary values. Stationary values is when dV by dx equals a particular thing. Check your notes for chapter 6 for the definition of stationary values if you've forgotten it. Set up an equation and then simplify this equation to that. Just harking back to B.1, dV by dx, you may have noticed all the terms were divisible by the same thing, but you must not, in B.1, divide through by that something. You can't divide an answer through by a convenient number. Once you've got it equal to a particular value, and you can divide the whole equation through by that answer, that's one of the things you're going to need to do to get down to this level. But do it in B.2, not B.1. Okay, another massive re-entry point here. Even if you couldn't do any of that, this is 2 marks for solving a quadratic equation, so that's 2 of the easiest marks on the paper. Part 4, explain why there is only one value of x which V is stationary, is quite likely to upset you, because you've just found 2 x's that will solve that equation. Quadratic equations usually have 2 roots. What you need to do is explain why one of those values just doesn't work in this situation. And to do that, you need to think about the original diagram back on page 1. Okay. In this diagram, x can't be any old thing. The rectangle only measures 24 by 9, so in fact there's an upper limit on x, as well as clearly x can't be negative. That doesn't make sense. So one of your answers to the quadratic equation is either going to be too big or it's going to be negative, and you need to explain why for this 1 mark. Okay. C.1, find d2v by dx squared. Okay, that means you differentiate dv by dx again. You should have the correct dv by dx. Remember, you should not have divided that through by a number just because you felt like it. So you take the proper answer for dv by dx and differentiate it again for 2 more marks. And then your notes for chapter 6 at the beginning about stationary points tell you how to use d2v by dx squared to recognize, in many cases, a maximum or a minimum. And this is one of the cases where that recipe works. Use your x value together with that and make a decision. Good luck with this question.